Hey folks, Jonathan here. Good news, bad news, I don't know. Got my phase converter and did not notice. This is my original old phase converter. I had this about 15 years. Good, good box, worked great. I had a 7.5 horse idler motor running this, or this was actually starting a 7.5 horse motor. Phase converter, the way it works, a rotary phase converter, you've got an electric motor that is a three-phase that runs, that actually, I guess you could call it, makes the other phases you need to run a three-phase, equipment. And don't get me wrong, I'm not up on it completely, so I'm not sure how all the phases work or anything like that, but I do know this much. You got to have this to start the motor, or you can use a rope, I've actually seen people do, or a pony motor, which is an electric motor just to help it out to get the your three-phase converter started. I've always used this because this was actually given to me about 15 years ago and it was already set up, and used it for a long time. Like I said, I got a 7.5 horse idler motor. When I picked up that 7.5 horse chop saw, it would work, but I guess it draws down on my idler motor and then it kicks the box back on. Of course, I'm not there watching it because I'm cutting, and I messed this box up. So I bought another one. This one, just like it. Messed around and burnt this one up, and I knew it was my own fault. Now this is maximum horsepower, 8 horsepower, but I pulled too much of a load on it and burned it up, and that's just all there is to it. And so this I bought in last June, no warranty. The company I bought it through, so no problem, no big deal. Talked to y'all about this the other day, that it was my fault and all that, so I bought this other one. And I did not realize, this one says heavy duty, this one don't. But now if you look at everything about it, the full load, the 22 amps, 4 to 8 horsepower, and that was 4 to 8 horsepower, and 60 hertz, both of them. Everything reads the same, but now when you pick them up you can feel that this one's about half the weight as this one. Put this one on, and of course I decided, well, I'm not going to run my 7.5 horse chop saw no more, so that should solve my problem. Well, it didn't, because I turned it on, checked my my machines, it was all running fine. I turned my lathe on, which is 5 horsepower, and it lasted about 30 seconds before it smoked that box. And I actually called and talked to the factory, and they wanted to know if I bought a heavy duty or light duty box. I didn't realize that I was buying a light duty. I didn't even realize I bought a heavy duty when I bought this one. The same part number, except this one don't have an HD and that one does. And kind of weird, but so my new box is burned up too. So they're going to actually exchange it, and I'm not sure what I'm going to do. And kind of weird that 4 to 8 horsepower. I was running a 5 horse and running a 7.5 horse idler, and I mean I was well within what they call for running, and but it still burned up. So I mean it may have had other problems, but either way I'm getting another one. I decided to go with a pony start on my motor, and I've just got a temporary pony start set up because I need to do the machining, and it's been raining for the last couple of days, so I can't be out working. So I've just got my pony motor just rigged up. It's not set up right or anything like that, but I'm going to show you how I started either way. Okay, here is my power box, and these are the 3 wires that actually run out to my phase converter, and I'm going to leave them like this temporary. And I've got this in a place where nobody's going to be walking by it or anything like that, but this is going to be just a temporary setup until I decide what I'm going to do, whether I put another static converter on it or not. Here's my idler motor. This is 7.5 horsepower, and here is my pony motor, which is just a little small motor. And but what we're going to do is put the belt on it and use this one to get this one spinning. Once we get this one up to RPMs, then we just turn the switch on, and I'll show you. It should start up. Now that we've got it spinning, I'll just reach up and flip the switch on. and then take this one loose and pop the belt off. It's about that simple. I mean, I need to get it set up on a, you know, something permanent if I decide to run it permanent this way, but I'll flip down and turn this little motor off, and this is an old motor. I don't think it's about 1 horsepower, but it wouldn't take much. But all you've got to do is get your idler motor to spinning, turn it on. You know, you really don't have anything extra to make a phase converter. Just you got to have your 220 single phase and an idler motor, and then of course the way to start it. Now, like I said, I was using a static box before, and this is just a pony motor start. But it'll work for now, and that'll get me to machining anyway. And you know, once I start that up, I can leave it running. So, you know, it's not like I've got to do this, you know, more than once. If I want to leave it running all day, I can leave it running. And but anyway, we're gonna get the machining on the pins for the wrecker and for the rollers, and I'll show you more. Okay folks, went ahead and faced it off. Didn't quite face it all the way, but I don't want to make it any shorter than what I needed. I've got to take this down to 1.5 inches, and 1 inch down, this is what goes through our plate. So we'll go ahead and get it done and keep moving on. About right. I'd rather go just a little tiny bit small. I don't want to press them, but just right at 5 thousandths over, so I believe that'll be fine. And what we'll do now is make sure this is an exact inch. We'll come in here and clean this wall up, and we'll go ahead and cut a radius on the inside of this, and because that bearing's got to fit all the way, so we can't have a taper on it. So we're going to do a rounded radius down inside, just like the pins were originally on it. And I'll show you in just a minute how we're going to do it. Okay folks, I looked at the bearing. We do have a little bit of radius on it. Not a lot, but there's some there. But I mean, I could work with it, but I think what I'm going to do is go ahead and ground a piece of high-speed steel, and we're going to set it up and go ahead and just cut a round radius in it, about like the other ones. Just not, like I said, not just this deep, but I'll take the camera out there and get a picture of one of the other ones when I'm done, and you can see what it looks like, and excuse me, what I'm doing. So we'll go ahead and get set up and radius this one, see how it looks. Okay folks, it's wet out here, but you can see what they done for the radius here. You know, they actually took a curved piece and went in. So that's basically what we're doing. Don't look like they went in any toward the flat of the bushing. It just looks like they went in straight. And you know, it's rounded out. So that keeps you from having a sharp edge, because you know, the bearing's got some taper on it, but I know my plate don't have any taper on it. I could have put some on it, but I'll show you what we've got on the machine here. Okay, I don't know if you'll be able to see it or not, but what I done, but it's basically the same thing. I didn't quite go as deep as they went, but it's rounded out, and that way we don't have any sharp corners. It's all radius. And I'll get this out. And what we've got to do, we'll just machine once off the top of here, and then machine this down to size for the bearing, and we'll be good to go. Be 1 down and 7 to go. Show you more. Alright folks, as you can see on one of these bearings that this is inset a little ways, and my most important thing on these pins, besides, you know, the OD and making sure I've got enough radius, is to make sure that this is the right thickness here. And it's actually 350 thousandths on the others. That's what it measured out. So we're going to make sure that the center distance for our lip there is 350, And you know, this is not as important, and really that's not as important as what that is. So that's going to give us our offset on our bearings, and we want them all to be the same. And then we can shim them as we need to. But we'll go 350 exactly on that, and I'll get that knocked out and I'll show you more. Okay. Anyway, you can see our radius. I didn't put quite as much on this end, because that bearing's got a little on it. And this end, it's going to be welded on bottom and on this around the side, just like they were. But I'll get it all the way down in there. But that's how it's going to look, and then it'll get welded all the way around, and then I'll weld the back side, and we'll put the bearings on. And like I said, I'll put a little, I'm not sure what they used on them, Loctite or something. Some of them actually slid off by hand, and then other ones, you know, I had to pry off a little bit, but we'll get a little Loctite or something around them where they'll hold. And I got a little bit of chatter in here, but I'll try to get that straightened out for the next one. But come out pretty good. That's what we need. We just need 7 more. I still got to machine these, but got my phase converter up and running now, so you can probably hear it in the background, but I'll be able to get some stuff done now. So let me get some more of these pins turned out and show you more. Okay folks, we've got them all done. I think we'll wrap it up for the night. Just got to finish some machining on the plate, get the holes drilled and tapped for them, and then we can start putting this thing together and maybe get us a carriage going here before too long. But appreciate everybody watching, and subscribing, commenting, liking, and hopefully tomorrow I'll get some more done, but we'll see how it goes. Get done what we can get done. A little bit's better than nothing anyway. But bye.